stability of structure. So this is the outline of our lecture. In this lecture, we are going to cover up these topics like the introduction, then the equation of equilibrium, types of supports and restraints, and stability and determinacy, and then the idealized structure. Uh, First, we must know that what is free body diagram. Free body diagram is just a depiction of, or you can say this simplified view of our structure, which is isolated from its support or other members for the simplification purpose. So what is that free body diagram? Simply simplified picture of structure isolated from its supports, on which are shown all the external forces that act on the structure. And second point is, these forces include the applied loads and the reactions that supports exert on the structure. So let's understand this. Suppose this is your structure. This is a simply supported beam. Okay, this is a simply supported beam. So we want to analyze this structure, but if we see that there is a depth, there is a certain depth of structure, so we can't analyze it in this way, and it will be very difficult task if we use this. Okay, because there is another factor is there, which is the thickness of this beam, which is going to increase our workload if we consider this beam. So what we do for simplification purpose, we make the free body diagrams of this particular structure. Okay, so let's see, as we have clearly defined that in free body diagram we remove the external supports. So here in this diagram we have removed the external supports. Okay, but whatever external external load is applied, that will be there. Hello. Okay. Then there is a free body. So I hope this is clear to all of you that what is free body diagram. Free body diagram is just a simplified version of any structure whose external supports are removed, and in place of that we have used only the reaction forces. Then what are the equations of equilibrium? For the simplification purpose, we must know that there is a there there is there is three dimensions. There are three dimensions which mean in which we can move, or which we know. One is vertical direction, one is horizontal direction. Okay. Okay. Like for simplification, if you are sitting in your room, first analyze your room. How many directions are there in your room?
Or
Or
yeah, or six.
six. Okay,
Yeah.
there are six directions. One is going upward, one is going downward, one is going left, one is going right, one is going front, and one is going back. Okay, so in this way there are total six directions if you are inside a room. Okay, similar case is there because that room is a 3D structure. Okay, and in 3D structure these directions are depicted in only three directions, or only three way, like x, y, z. Okay, so similar case is there when we talk about the equilibrium. we talk about only the 2D. If we talk about the 2D structure, then we talk about only the two forces at the time and a moment generated out of the third. Okay. One is external horizontal force, another one is external vertical force, and third one is the external moment balance about any point, and it is caused maybe of the maybe due to horizontal or maybe due to vertical force, but we have to consider either only one at a time when we are talking about 2D structure. But when we talk about your 3D structure, these external forces will be three, and there will be three movements generated out of these three external forces. Okay, so it can be written like summation fx is equal to 0, summation fy is equal to 0, and summation mz is equal to 0. Okay, we are considering all the three directions, all the three dimensions, but let me clear you that fx is all the forces which are in x direction, summation of that will be 0, summation of all the forces in y direction or in y dimension will be 0, and summation of all the moment about z will be 0, about z, not in z. Okay, ye dhyan, just be clear in your mind. Then when we are talking about fx and fy, these are the forces in respective directions, but when we talk about mz, that is not the force in respective direction, this is about that direction. Okay, and we consider certain sign convention for that, like if fx means if your horizontal force is there, if that is in positive, positive means if that is in right direction going rightward, then it is positive force. So, and if it is going in left direction, then it is negative force. Similarly, if Fy it is going in upward direction, we take it as positive, and if it is going in downward direction, we take it as negative. Same is the case for movement. If movement is counterclockwise, okay, counterclockwise, then we take it as positive, and if movement is clockwise direction, then we take it as negative. So these sign conventions you must remember all the time because these are very important. Let's see how many types of supports and restraints are there. This is your roller support. This is your roller support. Okay, we show this roller support by just using a circle. What is roller support? Roller support, it is free to rotate. Okay, it is free to roll, but it cannot it cannot go in vertical direction. Means like it is free to move in y direction and it is free to move in z direction, but it is restrained in y direction. So there is only one reaction at a roller support, or you can say two reaction at a roller support if we are talking about 3D, and if we are talking about 2D structure, then there will be only one reaction, that will be in vertical direction. Then comes your hinge support. This is your hinge support, and this is a symbol which we use while solving our equations or our problem. Hinge support is something like it is free to move in that direction, but it is restrained in, or you can say partially restrained in xy direction. Okay, so in that case there will be only horizontal and vertical horizontal and vertical displacement, not rotation. There is no rotation possible in hinge support. There will be only displacement. Displacement means that one object is displaced from one place to another place, or you can say the position is changed. But rotation means it is revolving around the same point. It means its rotation, or it is, if the object is revolving around its own axis, its longitudinal axis, then we say it is a rotation. Okay, but here in roller support and hinge support, there is no such kind of reaction is taking place. So there is no movement in roller support as well as in hinge support. In roller support, there will be only vertical forces, and in hinge support, there will be only horizontal and vertical forces. But when we talk about your fixed support, this is your fixed support. Fixed support, as the name suggests, it is restrained in all the three directions, whether it is x, whether it is y, or whether it is z. All the forces, whether it is displacement, whether it is rotation, all the forces are restrained in case of your fixed support. Okay, so there will be three types of reactions in there will be there if we talk about 2D structure, and there will be six type of reactions will be there if we talk about 3D structure in case of fixed support. Okay, like one is in vertical direction, one is in horizontal, another one is about the third axis, which is movement. Let's see some pictures that how these supports are there. This is a picture of a column which is connected at its base, okay, here, and fixed connection to the beam at its top. So this is a kind of fixed support. Two as girders and floor beams are assumed to be pin connected to this column. Okay, so this is a kind of simply supported. See, there is a hinge support. Because this picture is not clear, so it is not visible that where is hinge and where is your roller support. But generally you will find your hinge in roller support in case of your bridges. And if you want to see a hinge support, just see your door. The support by which your door is connected, that is also a hinge. So if you see some element like this in any beam, or sorry, any bridge, then it is a typical rocker support, okay, used for a bridge girder. This is not a hinge. And these are the rollers. If you are able to see, there are certain rollers. Associated bearing pads are used to support the pre-stressed concrete girders of a highway bridge. And generally rollers are provided where there is a turning takes place in your bridge. This is kind of a hinge support. This is typical pin used to support the steel girder of a railroad bridge. So there is a hinge. Okay, there is also a hinge. See how a roller support looks like and how a fixed support looks like. Whenever you see such kind of arrangement, there will be a roller supported connection. And if you see totally combined or monolithic structure, then that is a fixed supported beam or fixed supported structure. These are pin connected, these are fixed because they are welded. Okay, but in this case these are not welded. So what is determinacy? Determinacy is means the structure for which all the unknown reactions can be determined using only the equations of equilibrium. Means if there are n number of unknowns, that unknowns can be if that unknowns can be found out by using the equations of equilibrium only, that is summation fi is equal to 0, summation fx is equal to 0 and summation mz is equal to 0. Okay, then we call it that structure a determinate structure. See, just see this diagram. This is a L type structure. Uh, it is hinged at one end and it is roller supported at another end. So do not bother about the external load supplied. See, in case of your hinge support, there will be only two friction forces. One is in vertical direction, another one is horizontal direction. And in case of your roller support, there will be only one force which is in vertical direction. So there is total only three reaction sources which are unknown to us. And how many equilibrium equations are there? There are only three equilibrium equations are there, which are fx is equal to 0, fy is equal to 0 and mz is equal to 0. So in this way we are having only three equilibrium equations. Similarly, we are having only three unknown reactions. So what does it mean? This structure is a determinate structure. So what is undeterminate? Structure which possesses more unknown reactions than equations of equilibrium is said to be indeterminate structure. Means if our unknown forces are more than our number of reactions, then we call it as a indeterminate structure. See, now the similar structure is there, but both the ends it is supported by your hinge support. Okay, both the ends it is supported by hinge support. So as we know that at every hinge support there are only two types of reaction forces. One is in horizontal direction, another one is in vertical direction. So at a single support there will be two, at another hinge support there is another two. So total four unknown reactions are there. And how many reactions we know? Equilibrium, static equilibrium equations are there. There are only three equilibrium equations are there. That is summation fx is equal to 0, summation fy is equal to 0 and summation mz is equal to 0. So there is extra one unknown reaction which is there, Because of that, this structure becomes an indeterminate structure. So now we talk about what is stability, or what is stable structure and what is unstable structure. Unstable structure is a structure in which there are insufficient number of reactions to prevent motion from taking place, is called unstable structure. Okay, if any structure there are insufficient number of reactions, there is an insufficient number of reactions to prevent it from taking a movement or taking a motion, then we call it as a unstable structure. Okay, otherwise it is a stable structure if it is able to take movement. See, this is an example of unstable structure. It is supported at both the ends. It is supported at both the ends by a roller support. Okay, so there is a only one reaction is there which is in vertical direction at each support. Means, what does it mean? This roller support is free to move in horizontal direction. So this is an unstable structure because if we apply a load over here, this structure will move either to the right or either to the left direction, and ultimately it will lead to the failure of our structure. So that is a category of unstable structure. Idealized structure, it is nothing like that. The structure which is made in a line form and supports are replaced with the reactions. This is basically, we are talking about a free body diagram. And this new line shape of structure along with the symbolic reactions applied loading similar to free body structure is called as idealized structure. Okay, let's see what is free body diagram. Ideally, your structure looks like this. This is your actual structure. Okay, but we cannot solve this structure by using our equation because there is certain depth or width of this structure is there. So in this way it is not possible, it is not easy to calculate the reaction forces at this particular beam. So for simplification purpose, what we have done, we have made a free body diagram of this particular structure by replacing the structure by line, by a single line, and just replacing the reaction forces by its supports. See, here support is there, it is just replaced by reaction forces. Applied load is also replaced by reaction forces. So this is basically, idealized structure is basically a free body diagram. See, this structure is there. We have made the idealized structure of this actual structure in this form. Similarly, this is a fixed beam connection. This is a idealized structure of this. This is another fixed beam, overhang beam. So this is also a idealized beam connection. Similarly, in our problems, we are going to use these kinds of structures. So Wait a minute, I'm going to give you certain for sorry certain example, more examples regarding that. Wait for a minute. Meanwhile, if you are having any problem, you can ask me now. Yes, any one of you is having any problem?
No.
Okay. This example is there. Okay. This is a triangle shape. Okay. This is only a triangle. And this is a pin jointed truss. Okay. Pin jointed means they are either joined by screws, nut bolts, or either by rivets. Okay. So this is a pin jointed truss. And what is he asking? In this question, he is asking about the determinacy or the degree of statical indeterminacy of pin jointed truss. So let's see how to solve this. First, you have to make a free body diagram of this particular structure. There are two examples. One is this, one is this. Okay. So we will see that how to solve this. So for the given truss, there are n number of members. N is equal to 3, and number of pin jointed pin joints are number of pin joints are see, all of you write in a copy, all of you write one equation. Statical indeterminacy SI is equal to, are you writing? Yes. Static indeterminacy is equal to m minus 2j plus 3. You have to use this equation. So this is the equation which you have to use. D is equal to m minus 2j plus 3. What is m? M is number of members. M is the number of members and J is the number of joints, pin joints. Okay. This equation you have to use while calculating your static indeterminacy. Here D is denoting your determinacy, or you can say indeterminacy. I hope all of you clear. Yes. Yes, tell me. So as you are seeing this structure and this structure, let's see how to solve this. Then after we will finish up your class. D is equal to m minus 2j plus 3. Okay. So this structure is there like this. And it is end support at one end and roller support at one end. Okay, so how many numbers of members are there in this figure? 1, 2 and 3. So m is equal to 3. Okay, now we will count how many number of joints are there. 1, 2, 3. J is also 3. Okay, so by using these two we can calculate our D, which is determinacy. So let's see. D is equal to m is your 3 minus 2 into 3 plus 3. Okay, so what it will be? First, according to bed mass rule, 3 minus 6 plus 3. Okay, so this will become 0. So what does this 0 signifies? That this particular structure is determinate. This particular structure is determinate structure. Okay, if it is this D doesn't come equal to 0, then it simply means that this particular structure is not determinate. This will be possible for all the times. Okay, this is the case for all the times. So just use the second structure. Just solve this one. By using the same equation, all of you fast, just solve this one and tell me whether this structure is determinate or not. I have very less time, so I am solving this one. Here your M.
9, sir.
Yes.
2 minus 2 into 2 plus 3.
I am solving this equation. Here your joints so your D will be 2 minus 2 into 3 plus 3. Okay, so here it will be 6, this will be 5, so it will be minus 1. So what does it mean? Because D is not equal to 0, so it means it is an indeterminate structure. I hope this is clear to you. It is,
Yes, sir.
yes, here it is one member and it is another member, so M is 2. It is joined at this point, and this point, this point, this point, and this point. So number of joints is 3. So we will put up this 2 in this equation, so it will be m minus 2 2j plus 3. So here it will be minus 1. Okay, so we will take up this in your next class. I hope this is clear to all. I am leaving this class. Okay.